Welcome to the tutorial on how to find slope, or the rate of change, also known as gradient. The general formula is slope, which we denote by m, is equal to y2 minus y1 divided by x2 minus x1. So what does that mean? Some refer to it as the vertical change divided by the horizontal change. Some people refer to it as rise divided by run. Some people refer to it as the difference between dependent variables divided by the difference between independent variables. So what does that actually mean? So let's look at the three different ways that we show dependent and independent variables. So the first one is by the arrow diagram. So if we look at this arrow diagram, the difference between these ones are the independent. If we look at it, the difference between 4 and 2, well, we know 4 minus 2, it equals 2, so that difference is 2. The difference between 6 minus 4 equals 2, so that difference is also 2. So I could pick these two, or I could pick these two to look at. Let's look at the dependent. Let's look at the difference between 9 and 7. And again, 9 minus 7 equals 2. And the difference between 11 and 9 equals 2. So I could look at 9 and 7 and 2 and 4. So I'm going to look at 2, 4, and I'm going to look at 4, 9. So if I'm going to write it by the formula, where my dependent are, I'm calling my y's, and my independent are my x's. So I have my x and a y, and I have an x and a y. So these ones are my first ones. These ones here are my second ones. So my y2 minus y1, well, that's 9 minus 4, because these ones are the second ones. These ones are the first ones. And then, of course, my x2 minus x1 then is 4 minus 2. So this example, 9 minus 7. I just wrote this down wrong here. Let's put it as 7, fix it here. So I have 2 over 2, and of course that equals 1. Now I can look at using 6 and 11 and 4 and 9. So let's look at those 2 points. I always need 2 points. So these would be considered points. The points of 4, 9, and these are the points of 6, 11. So I always need to have 2 sets of points in order to find my slope. So I'm going to write it as m, because that's what I denote slope as. And again, 11 minus 9 divided by 6 minus 4. And again, that just happens to be 2 over 2, which is equal to 1. Now, if you notice, with this example, the slope comes out to exactly the same answer. So this tells me that these points all lie in a line if I were to graph them. They all lie in a line. So I could have many more points like that, as long as they have a difference of 2 between them, as long as this difference here, where my purple lines are, as long as that is the same between each of the points in my dependence, and then between each of the points here in my independence, the points all lie in a line. Let's look at it in a t-chart and see if that, with this example, if it looks like it lies in a line or not. So let's look at the difference with these ones. I'm going to mark the difference in green. So 2 minus 1, well, that equals 1. 3 minus 2, that equals 1. 4 minus 3, difference is 1. 5 minus 4, difference is 1. If I keep going, 6 minus 5, 7 minus 6, for my x's, or my s's in this case, which is still my x values or my independence, the answer is 1. So what about my dependence? So let's look at the dependence here, which are my m's, my distance, so they're denoted in meters. These ones time. So my distance, let's see. Distance between 4 and 7. So 7 minus 4, well, that's 3. 10 minus 7, 3. 13 minus 10, 3. And as I keep going, it's 3, 19 and 16, 3, 22 and 19 is 3. The difference between each of them, again, is 3. Because the difference is the same between each of them, again, that tells me that these points all lie in a line. So these are a linear relationship between the points. So again, if I graph them, they would all be in a line. So let's look at if I actually didn't do this activity where I found out each of these in between, but instead I just picked 2 with the points. So let's look at 1 and 4 and 2 and 7. So those are my 2 sets of points that I'm looking at. So again, I'm looking at my change in distance divided by my change in time. So I'm picking, here's my distance points. So I have 7 minus 4, and my time points, 2 minus 1. So that equals 3 over 1, which is equal to 3. Let's look at a different set of points. What if I picked 7 and 22 and 6 and 19? Will it be any different? Well, again, my m equals the change in distance over the change in time. So between these points here, I'm looking at 19 minus, 22. 22 minus 19 over 7 minus 6, which again is 3 over 1. Now you might be asking, why am I saying, even though I wrote this one first, these are my second set of points, because 7 comes after 6. These ones are my first set of points. And of course that answer equals 3. So again, I have the same slope. That also is an indicator that these points are linear, or that they lie on a line, in a line. Let's look at this graph. So if I'm just given points on a graph, what do I do with it? So I'm going to again look at this rate of change, and this time it's again distance and time graph, just the way that it happened to be. It could have been x and y, it could have been time and temperature. We could have had different things, but this scenario I took was rowers, and so the rowers go a distance over a certain set of time. So we're looking again at the change in distance over the change in time. So, and I've been given 2 points here. I've been given the point 85, 500, and then 180, 1,000. So this is my second point. This down here is my first point. So these ones have my x2, y2 values, and this one has my x1, y1 values. So my change in the d's, so I relate it to x2, y2 just because of the general formula, so you can relate which ones are going to go on the top. So we have 1,000 minus 500 divided by, and again, there's my x2 value, 85 is my x1 value, whoops. So let's actually write 85. And of course the answer to that is, when you do it, it is 500 over 95. And you can actually find out what that is by putting this in your calculator, and it equals 5.26. And remember, this is meters and this is seconds, because we can see that here and here. So that means it's meters per second. So 5.26 meters per second would be the rate of change between these distances. So what happens when we're looking at something that is not linear? So if I look at different points, let's see what happens. So we saw that in both the T-chart and the arrow diagram, that the difference between each of the points was the same. So we knew it was on a line. If I took different points, again, the slope is the same, so it's on a line. The same would happen in our graph if we went longer. So if this line happened to extend sort of further up, it again would be linear as well, because the change would be the same. That is the definition of a line, that the slope along the line is exactly the same. Doesn't matter what 2 points you pick. So let's look what happens when it's nonlinear. So let's look at the parabola here. We have the function notation f of x equals x squared minus 1. So the first points I'm going to look at, the difference here between this point and this point here. So we have the points 1, 0, and then I have the points, let's put it first here, 9, minus 1, and 0. And then we have another point, we have 2, 3. I have other points of minus 2, minus 1, minus 1, 0. Getting a little excited here. Minus 1, 0, and then minus 2 and 3. So I have different points to choose from here. So let's take this point and this point first. So the first one I'm going to look at, I'm going to call this A, and I'm going to look at the difference, so my slope between those points. So I have 0 minus minus 1 divided by 1 minus 0. So what does that equal? I have positive 1 on top and I have positive 1 on the bottom. The slope is 1. Okay. Now let's look at this point and this point here. So 1, 0 and 2, 3. So I can do this one in green. So I have 3 minus 0 divided by 2 minus 1. So 3 minus 0 is 3, 2 minus 1 is 1. Well, the slope is 3. Okay. These are not the same. So then I know this is a non-linear graph, because this distance is not the same. My rise over my run for this point compared to that point, they're not the same. What happens on the other side though? So what happens if I look at this side of the graph? Well, let's look at 1 minus 1. We'll look at this point, 0 and negative 1, and then I'll look at negative 1 and 0 and that point. So let's see what happens there. So again, I have 0 minus 0, 0 minus minus 1. And then I have minus 1 minus 0. Well, that equals 1 on the top and minus 1 on the bottom, that equals negative 1. Well, hold up. That is opposite to this one. It's a negative slope of what we had in the orange. Okay, let's see if something else happens here. So now we're looking at negative 2, 3, and negative 1, 0. So I have 3 minus 0, okay, divided by minus 2 minus minus 1. Okay, I have 3. So minus 2 plus 1 is minus 1. That equals negative 3. That again is different than 3. Why is that? Well, let's separate our points. And I'm going to draw them as two different. So I had, this one started here. This was our common point of minus 1, 0. Oh, sorry, 0, minus 1. Again, getting a bit excited here. So I have minus 1 and, I did it again, 0 and minus 1. There we go. So let's get our point up here. And there she is, 0, minus 1. And then we had here and we had up here. So this one was 1, 0, and we have 2, 3. So now if I look at the other half of the graph, where I had minus 1, 0, and then here I have minus 2, 3. Anything lying sort of in a left to right, so if I started at this dot and I rose up, so it's rising sort of up and to the right, these are going to be positive slopes. So that makes sense for the orange line here, because all of these are lying sort of in that up towards the right. Now if I look at the other side, they're going the opposite direction. So they're actually going up towards the left. These are going to always have negative slopes. Let's fix our spelling here. They're slopes, not slops. This is important to note. We have positive slopes when the lines are up and towards the right, negative slopes when they're going to be up and towards the left. So that makes sense now that we have positive 1 and negative 1, positive 3, negative 3, because these ones are lying up towards the right, so they're positive, and these ones are lying up towards the left, so they are negative.